The main aim of virtual reality is to provide a natural, free-flowing, and enjoyable experience for the user.
This is virtual reality.
Environments can be completely computer-generated, eliminating real-world perception, or integrated within real-life environments. The goal is to recreate real-life scenarios or to fabricate new environments with computer graphics. With head-mounted displays, usually two screens are used to create a stereoscopic image. This causes the same effect as the separation between your two eyes. The conjunction of the lenses and the angling of the screens mimic how the human eye perceives depth in real life. It uses tech components such as an accelerometer to measure the orientation of the head and for tracking of the position in the environment.
VCG is a very large area, and what we're mostly interested in at the moment is capturing the real world, so buildings, people, objects. Until recently this was only really possible with very crude representations, but now we've got much faster computers. It's much more easy to make a sort of a very plausible representation that people can interact with inside, say, a virtual reality system.
Virtual reality provides a realistic, risk-free simulation environment with numerous usability and cost benefits to many industries. A few of them are
Communication, for example, Star Wars-style business meetings.
Medical and military training for surgery or combat simulation.
Design and architecture.
In museums for documentation, archiving and restorations.
Virtual environments today are visually unconvincing as the graphics are of low resolution. To render top quality 3D graphics is difficult as it takes an immense amount of processing time. More efficient algorithms are being developed in order to overcome this problem.
Besides that, the limited vision field of VR headsets is also an issue. Technically, the human eye has a peripheral vision of 180 degrees, but an average VR headset today supports up to only 120 degrees of vision. The human brain is able to sense this, and the virtual environment experience is disruptive.
Furthermore, low frame rates is also an issue in VR. Securing a constant high frame rate while maintaining top-notch graphics quality is extremely difficult. As a result, we're vulnerable to experiencing virtual reality sickness, which is a form of motion sickness.
Virtual reality can raise various ethical issues. Have you ever thought how a criminal in a virtual reality world would be judged? Would a criminal in a virtual world receive the same punishment as a crime committed in the real world?
Cyber sexual harassment has been rampant in online gaming communities as well as social media. In the past, these harassments took form of either verbal or visual messages. The introduction of virtual reality causes virtual abuse issues.
An interesting research area is retinal resolution. It is such that your eyes would no longer be able to physically discern the individual pixels on your screen. It could make technology seen in movies such as The Surrogates and The Matrix a real possibility.
Despite all the limitations we've mentioned, prices of VR technology are decreasing, with products like Google Cardboard and science behind it improving dramatically.
Research is in many areas, a big one being seamless interaction within virtual environments. Imagine if you could feel, touch, and even sense heat. This could bring a real sense of control to the environment. This area is called haptic feedback.
The idea that we have a desktop computer and a phone, or maybe we have both, is going to go away over the next 10 years and be replaced by an augmented reality model where you will be able to use a computer wherever you are, and this will change how we think about programming computers and how we use them in our everyday lives.